Am I hosting?
Yeah.
All right, welcome everybody to another episode of the JUXT Season 5. We're very happy today to have a guest called Jake. Hello, Jake. Could you just say a few words and introduce yourself?
Hey, yeah, sure. I'm Jake. I am a software engineer. And I think in this context, that's probably all there is. I'm at the coalface. I work on problems 5 days a week. That's what I do.
And you know John, don't you? John Pither, who's joining us today. How do you know John?
Yeah, well, Jake is a friend of mine. We live in the same town, and we go out for lunch and coffee, and we often sort of get around to the same topic, reminiscing about the excess of types and how that can cause lots of waste on software projects, something we're both passionate about. So Jake has written up a bit of a thesis of sorts, and I thought, well, we haven't had one of these talks for a while where we sort of, let's get in there and, let's have a bit of a slap down on things like typing. So looking forward to this, and it'd be great to get into it.
I love bumping into people in coffee shops and having that conversation about types. It's a good, a good conversation starter. Anyway, Joe, how are you?
Yeah, good. Thank you, Malcolm. Keen to again get into the types battle. I wonder, it's one of these sort of long, raging debates, I guess, isn't it? And we've at JUXT, we've had a background, I guess, an affinity with dynamically typed languages, and so there's probably a lot of people in JUXT that have this already are pretty comfortable with the idea of dynamic typing as a superior route. And so it's interesting to I don't know, have a bit of a tougher conversation and have these foundational principles challenged. Is going to be fun.
I think Joe is pretty well qualified. I mean, Joe is probably the person in JUXT with the repo on GitHub with the most amount of stars. So it's got 6.2 thousand stars, 1.7 thousand forks for JSON schema to Java POJOs. So it feels like you're right in the sweet spot here, Joe, of helping to advise us on this subject.
Yeah, I guess. I mean, and it's not, that's not a dynamically typed language, right? To my shame, it's not one of my Clojure repos that's got the most stars. But I think it's good. You got to get in there early, get in there in the early days of GitHub, and you can maximize your star count.
Okay, so let's start from the beginning. Let's define a few terms. What are we talking about when we talk about a type?
Yeah, that's an interesting question, actually, isn't it? What does it mean to be dynamically typed? What does it mean to be statically typed? And I think the definition is actually really boring. In a statically typed language, the compiler knows ahead of time what type your variable is going to be, and you can't change it afterwards. But I don't think that speaks to the kind of stuff that we're going to get into at all, in my opinion.
Well, let's start with I think many people, especially entering the industry today and becoming software developers, and maybe their first language will be JavaScript, they'll probably think, that JavaScript, you get lots of bugs if you don't have a type system, and it's, those bugs take ages to solve, and it's really annoying. And then if I sprinkle a bit of this magic fairy dust called TypeScript over it, then these issues disappear. So somehow JavaScript was a language that was created where they just probably didn't have time, or they forgot to add a type system, and the heroes of Microsoft come along and they just almost finish off the language by adding the missing feature, which is the type system. And I think that's how a lot of people see the debate, especially on Twitter and social media, as kind of somehow dynamic languages are a little bit kind of basic and inferior.
Yeah, I agree. I think there's definitely a sort of typed languages are superior to dynamic languages thing going on. It's interesting, I think, where you came from, not you, but where one comes from with the static dynamic thing. Because as you say, if you come into JavaScript and TypeScript gets layered on, I think it's fair to say that could be an improvement. I use TypeScript at work. And I think as much I do love dynamic languages, I quite enjoy writing JavaScript without TypeScript on top. But there are a few sharp edges which TypeScript takes off, and it's quite easy to escape the type system if you want to.
Can we get back for our listeners to defining these terms? So TypeScript is not statically typed.
TypeScript's a funny language, isn't it? It doesn't fit cleanly in to the definitions, and the definitions are a bit loose. So no. So if you let x equals 10, then you can say x is a string afterwards, I think, which I never do. So I've not actually
So it's like layered typing, layered schema onto.
Can you?
But maybe for those that haven't sort of used TypeScript, like what's the relationship between TypeScript and JavaScript for those that are not familiar with that ecosystem? I guess would be a good place to start.
Yeah, I guess given I use it, I should probably answer and show you how little I care about these things. But really, TypeScript is a linter for JavaScript, right? You're fundamentally writing something that's very, very close to JavaScript in terms of syntax. You can layer on type annotations in your code. So your source file's got these essentially annotations, and then you can run it through a preprocessor which checks some rules for you and then turns it back into JavaScript for execution. So that isn't perhaps quite the same as something like Java or C++, where it's not Java isn't a dynamic language that someone layered on some annotations. It's a statically typed language designed that way from the ground up.
So clearly, you have in TypeScript you have a compiler.
Yes,
and which you have to run on the command line, and it will turn your TypeScript into JavaScript if you have obeyed the type rules and there are no validation issues.
Yep.
So that that's kind of, I suppose, a weak definition of a statically typed language is that there is something that you have to run, a compiler or something, or a linter checker, as part of your development flow.
Yeah, I think that's fair. And going back to I guess it's not that simple. Dynamically typed languages can be compiled. So just having a compiler doesn't make it statically typed. But yeah, I think if it's statically typed, it has to be compiled, doesn't it? You've got this.
And you said why you quite like writing JavaScript without TypeScript. Can you kind of delve into that? Or why is it?
Yeah, so I've got a whole spiel about the downside of types.
Let's hear that.
Oh, I mean, yeah, I don't know if I can weave it all into answering this question, but I think to answer your question first, I think for certain problems, the type system gets in my way. I don't feel like the cost benefit trade-off is in my favor. I want to do something relatively straightforward. Maybe I can achieve what I'm looking to do in a handful of lines of code, a few functions, and I don't get any sort of meaningful extra confidence from the type system and all of the baggage that it brings with it. So I don't think it's a good trade-off. And I think sometimes it actually makes my code worse to have to type it up, or quite often, in fact. But yeah, I've written down a whole list of points of what I would think of as perhaps the downside of types. So I'm not quite frothing at the mouth anti-types. I've probably spent about 50-50 in terms of my career writing type languages or dynamic ones.
Well, let's indulge ourselves. I mean, let's allow ourselves this. Like, this is our podcast. We want to do this. We want to get into the red meat of it, and we want to explore the downside, and then maybe we can come up with a spirited defense. So it's not all one-way traffic. Drum roll, Malcolm. We're going to do. Can you press a drum roll button? Yes, already. Good enough. So we're going. So Jake, lead us through your top 5 and possibly more. Try and be pithy with each one, but let's start with the first one. What is the first one that you got there? Presumably the one you feel most strongly about. Hopefully, what is your biggest concern with typing?
I'm not sure my top one is my biggest one.
Doesn't matter.
I'm already failing at the succinct bit, aren't I? So I think you have a certain number of chips to spend when you're actually trying to solve a problem for someone. There's only so many hours in the day, right? I think often I've seen people spending quite a lot of time having solved the problem. The code is working, then spend an extra few hours satisfying the type system. And I don't think that's necessarily a good trade-off. I think you could use that time more effectively to...
I can add a kind of anecdote to that, because that definitely does resonate with me. I remember having whole evenings with Eclipse and IntelliJ, or used to, and having especially when generics were a thing, and you'd say, I've got it down to less than 2,000 warnings, and there were no errors in the code, it was just warnings. And then sometimes you'd get down to 0 warnings, And then magically Eclipse would just decide change its mind without you changing any code and said, oh, and actually it's 27 warnings. And you were sort of fighting this warning battle, but you knew that you had to get rid of these annoying yellow warnings. But it was almost a sense of a bit like the satisfaction of solving a useless Sudoku puzzle. It was a kind of nice, oh, I spent 3 hours doing that, and you didn't feel like you'd created any business value or anything, but you had, you were left 10 p.m. at night, you went home knowing that there were no warnings.
I couldn't have put that any better. Has anyone tried to build a builder class? Do you remember when you wrote DSL? So you'd have some Pojo thing you want to create. Before that, you'd probably have a factory class or something. Whereas now you've got these DSL builders trying to get the generics lining up with the flow method. So build with this and with that. That's absolute carnage. It was just like you say, it was like a Sudoku puzzle that would just suck in hours and hours. So we've got the first one there, which is just time spent. So that cost benefit trade-off. But then, what about the argument against that? But this is a conservative approach. It's like, in the long run, this is better because we've got checks and balances.
Yeah, I think like most things, it is a nuanced argument, isn't it? And having spent so much time with TypeScript lately, where you can layer on the types as much as you want or as little as you want, I would definitely be lying if I said that 0 types is the best outcome. I think if you have that choice where you can say, well, they're useful here, but they're not useful there, so I'm going to just choose to apply them there, then yeah, I think it can be worth the investment in the long run. I think probably the thing that I want to communicate most on this podcast is that people should be actively making that decision, that they should be thinking about whether that trade-off is in balance, and not just default to the mindset that says more types are better.
Yeah, something to Malcolm talks about a lot, which is this separation of code and form, and to regurgitate what you just said, if you start with a statically typed language, you often have those two things married up. So the shape of the data, you're immediately codifying that and putting it into code. But there is often a better way, isn't there, Malcolm? If you can find a way to split those two, could you talk to that?
Yeah, I can. I mean, I think people do tend to use the type system to start putting names to things. I think naming is quite tough when you've got to think, oh, I've got a collection of strings. What shall I call this? And when you use the word builder and you've got to, but often you creep into doing domain-driven design through the type system. So you start labeling thing, address, date of birth, and that has to be a date. And and so you start building up this type hierarchy. And I think my problem with that is that you end up writing code that is fixed to the current domain. And the one thing that we know about the domain is that it changes either through your understanding improving of your domain, because your domain is only an approximation of reality, and sometimes you want to approximate things in different ways, and so your domain evolves. And sometimes the domain itself does actually, new market changes, the world just changes and the domain does change. And so if you've codified your domain inside your code base, one thing that's guaranteed is if your domain changes, you're going to have to change your code. Now, that's a sleight of hand, really, because people have created environments where you can change code really quickly, runs a test, CI/CD pipelines. So they don't quite notice that actually any change in their domain, really, that should be a data change or a configuration change, actually requires a code change. And I think that's something doesn't sit right with me. Coding, we worked on different systems where the entire domain is all coded up into classes and stuff, and they're very, very brittle. So I think there is something in dynamic languages which is, rather than static strong typing and dynamic typing, maybe we should call brittle systems and flexible systems, because the language just can indicate that.
I think it's there's big systems that we see, there's often more than one domain there. So you have a domain of like the infrastructure, the capability, chasing things like SLAs and trust and what goes into what that system can do. And then there's often a domain towards the data itself, which could be like, trades or stocks or prices or holidays, the actual data domain. And I think that these two are not so often teased apart. Like one is like the underlying platform that serves this data, that often you probably do want to put some types around, like, we're going to call this service, this is what we get back, we want those schema checks, those type checks. That's really useful. But that people don't distinguish between those two. And if you just start with types for everything, that line becomes blurred, and you're not quite understanding or making that conscious choice as to when we're entering that data domain. And the argument is, well, if you start from the other side of the fence, let's not put types unless necessary, then we can make that distinction clearer.
And I think probably the most nefarious version of this is something you're probably most likely to come up against in an object-oriented language, probably Java, where your address class, it's glommed together all the functionality, all the data, and then it's nominally typed. So if you have something else that is addressed like, you have no reuse at all. You can't pass it in to the thing that takes addresses. And if that, as you were saying earlier, if that gets through your system, it's incredibly brittle if you want to make a change. So you've got no leverage to begin with, and then you're absolutely locked into your choice. And I think you ticked off two of my points already in there. And I think that's the kind of thing that when I come up against that makes me want to stop coding. I don't enjoy working on those systems. It's very, very hard to make progress. You have to do a lot of work to make a small change. And yeah, not my cup of tea at all. So.
I think there's also there's a capability that's missing as well when people codify up the types, the schema. This is something else that I want to ask Malcolm about, because he talks about this. But it's, if you've got your types and schema and data shapes in code, how would you discern what types and shapes you've got? Like, how often have we seen people use the Java reflector to go through fields on a class to work out what is the shape of data that this thing really is, and doing horrific things? And it's very, very slow to do that. Whereas if you have your schema as data, that's tremendously powerful, isn't it?
Yeah, I think so. We talk about shapes being the what we say form is actually the business understanding of the process, or the way that businesses evolve, and as they get more understanding about their domain, that's encoded in what we call form. Now, if form is internalized in a program, you can't see it. You have to sort of reflect on it. I think that's a good point. You're not only limiting, you're encoding your form inside the code base, you're limiting it to, let's say you're writing Java, only the Java programmers are going to be able to use that codified. The Python people might have to do something equivalent, but they may make a different shape, and they don't interoperate. But I think, Jake, you raised an interesting point there, where even within the same program, you might have two parts of the program that have this idea of an address, but they're not the same, and you can't reuse the class. And you encode, you tightly weld the operations that work on that structure to the structure itself. And it's that Alan Perlis epigram about you want to write 100 functions working on one data structure rather than 10 functions running on 10 data structures. It's a kind of the lack of flexibility, even within the same code base, where you're sort of locked in, and you then have to think, do I have to create a superclass of the sort of address base? And you're constantly working around trying to pass data across to different parts of the system and adapting it and doing all kinds of work to fight against the type system.
And I would say, in my experience, that can be 60% of the work. I'm literally spending more time on doing that stuff than I am actually solving the problem. It was a 2-minute job to say, well, there's the function, I've got the data, I want to put the two together and get the answer. And then you go on this massive merry-go-round fighting the compiler. And as you say, making quite difficult design decisions, which I argue you just don't need to make. You have to do all this design work, and it's hard. And I think maybe it appeals to people's minds who like puzzles as well. And I'm not like that. I kind of want to get the job done. I'm not that interested in sort of doing Sudoku puzzles at the same time.
You often see, don't you, some compromises where you have a big system and there's a data domain that's codified, and then this whole war starts breaking out with generics and inheritance hierarchies and class hierarchies and mix-ins, like weird sort of patterns that people have introduced to try and solve this problem, try and make things more composable. But what you often end up with is people give up and they think, actually, for this little bit, we're just going to go back to hash maps. And it's that classic smell that you need that dynamism in your system, and it's broke out here. but then it's never done particularly well. It's always like, well, some things are in the hash map, some things aren't in the hash map. People feel uneasy about the hash map because it's not first class, for example, in something like Java.
And I think you always find them, don't you? I have this mental image of a jigsaw puzzle that you build from the outside. Sorry, you build from the outside, and you get to the middle, and you can't find a bit that fits. And you always end up there with these mathematically defined systems. Unless your system is coherent, properly coherent, you get to that bit where there's this incongruity and you can't overcome it. So you're like, oh, well, cast it to object and smash it in a map and move on, I guess, because you can't do anything else.
Yeah, it's unforgiving. It requires, and that's almost where, because you need to get to that congruity, as you say, then the approach is to just, let's just keep refactoring and that changes type signatures and breaks compatibility and all sorts of things, but it's just constant. That's what I feel when I'm working in a language like Java, that I'm just constantly going home and thinking, I could do it a slightly better way, or there's another improvement, and it's an endless road of improvement. And it's actually a bit, is it really an improvement? It's a step along a road of improvement, but there's something a bit beguiling about it, and you're getting this hypnotic trance of thinking you're improving a system. In fact, you're just changing it.
Yeah, I think that's a really important point, that the human factor. And I've had similar experiences and then got huge dopamine hits from solving the problems. I said I don't like solving puzzles, but I guess I do like success. So you get this huge, very rewarding feeling by struggling against it and then succeeding. And as you say, you think you're adding value, and you could lose anywhere between days, weeks, months to years solving those problems. And if you think about economically what that means, paying people a lot of money to solve these problems and how much value are they getting out the other side, I think there's probably a case.
Well, don't ask that question, because I was going to say the reason we can do refactoring in the first place is because we have a whole bunch of tests that allow us to make refactoring cheap. And so it becomes self-serving. The whole thing is circular. You build the tests so you can refactor stuff, but really, what are you just doing? You're constantly tinkering with the code. And I think the fact it is beguiling means that we sort of see value that perhaps isn't there.
Well, we've seen places that monitor, productivity by engineers, and if engineers are going in there, they've got to change that domain. They'll constantly be tweaking the code, and then it's sort of, as you said, self-serving.
Their productivity scores will still be quite high because they'll be adding and deleting lines of code, and it's very difficult to tell really whether value is being added or not, because that's something that's measured outside the system.
It's activity as opposed to value. I mean, there are some real costs, aren't there? Like, I think that if the OO graph or the type hierarchy, if that is pervasive and it goes through a system, that makes that system incredibly difficult to break apart. And then you get what people call that big ball of mud. And it's a types that entwine it all together. And I think that's when things like microservices really hit off, because people are like, we've got to avoid this big ball of mud. How do we do it? Let's just go microservices. Whereas actually, if you started with a more dynamic approach, the code won't be as big. It might be more modular. You might be more at peace, actually, with keeping it in the same process, the same code base, without having to split it up.
Joe, do you have anything to? You obviously you've gone through a career writing OO, Java systems, JavaScript, and Clojure.
Scala.
So you've kind of got.
Yeah, it's interesting, isn't it? I think it's often, as we've already said, it's inevitable that you end up with areas of a system that require more dynamism. And so in the Java, it's like everyone's worked on a Java code base, as you say, John, that's got this kind of area where we're doing a lot of using this sort of Java reflection APIs here, and we've sort of jumped into like dynamic mode here for, some reasons. I think that's this idea of gradual typing, and this is also what TypeScript has brought to JavaScript, right? Is the idea that actually you can take some areas and you can apply types or rules to the areas that makes sense, but you've kind of still got this capability to move between two different worlds, the kind of dynamically typed world and statically typed world. And that, it turns out, it allows areas of the system to only start to codify the parts of the domain that they're interested in and leave the rest alone, which is a very powerful, pattern, right? Especially when often what we're doing kind of does feel like plumbing. You're actually just moving data around from A to B. You might be doing some transformation. The fact that you don't need to codify the entire domain to do that, you can actually just focus on the bit that's relevant to you. Even if you want to introduce types or schemas or some kind of validation of the changes that you're making there, you can leave the rest, you can do that in a gradual fashion and leave the other parts of the the data domain alone. That turns out, I think, to be a very powerful pattern. And so it's no surprise then that those systems that offer this gradual typing are the ones that, like TypeScript, have become very, very popular. One thing that I wonder, though, sometimes is that JavaScript is a very, very successful language. So it's super, it's probably, as far as dynamically typed languages go, it's probably the one that everyone has used the most. And we've sort of done it a little bit in this podcast, where people talk about strong typing and weak typing and static typing and dynamic typing. And there's all these terms kind of conflated. And sometimes I wonder whether a lot of the, when people talk about dynamically typed languages, they bring some they have some conceptions about the chaos that is ensued by that. But actually, what they're mostly feeling is discomfort with the idea of weak typing. So, the fact that, in C, for instance, we can treat a value. We don't actually know what the type of this value is. It's a weakly typed language. We can take a piece of data, we can treat this as an int, or we can treat it as, a variety of different ways we can decide, okay, this represents all possible types. And the same is true in JavaScript, right? Everyone's seen those tables of hilarious ways in which we can interpret a value. If we interpret it as a string, it looks like this. If a Boolean, it looks like this. A number, it looks like this. And in fact, this isn't actually the experience of most people using dynamically typed languages. There are many dynamically typed languages that don't allow this kind of weakly typed madness of being able to interpret values incorrectly as many different possible types. All they're really doing, they are providing a strongly typed environment, and all they're really doing is saying, we'll be flexible about the aggregates. We won't necessarily dictate and try to codify all possible aggregates that need to exist in our system. We're not saying, if you create an int here, guess what? We're going to treat it as a string over here, and we're going to just bounce between these different, quite fundamental types in a way that's quite dangerous. All these dynamically typed languages are saying is when we think about aggregating these things together, that's where we start to get into trouble, because there are different parts of the system that want different subsets of those aggregates. And as soon as we actually decide on what those aggregates should be, they may not be identical. And it may be the case that we end up, we might just start having to map, endlessly map between one set of aggregates and another set of aggregates. Or we might say that, there's some huge aggregates here, and I only care about small parts of these. Or there's some variation, and some part of the system assumed that this aggregate was always would always, everything within that aggregate would come together. Another part of the system, actually, in this area, some of these parts are optional. And it's like these aggregates, and what dynamically typed languages allow us to do is say, yes, we're going to remain flexible about the aggregates, but we're going to make it as easy as possible to interact with these sort of, heterogeneous kind of aggregates that have this dynamism. We'll make it as easy as possible to interact with them. Whereas things like Java and the statically typed language, what it's saying, even using the collections and having to provide that generic type, no, there's only one type of value that can go in here. What it's saying is, I'm going to be strict about these aggregates. But I think there's an issue there in that we're often working in a world where we want to be more flexible about those aggregates because so many of these variations exist. But fundamentally, I think if people see dynamically typed languages as, I'm going to enter the world of weak typing, that is what I think often will put people off, and especially because their common experience of this is JavaScript, where we all know how wrong things can go there.
I think that's a key differentiator, to understand the difference between aggregate types and what I'd perhaps called atomic types, or the string, the ints and floats. Straw man arguments are erected to say, isn't it crazy that we can turn an int into a string and we get a kind of buffer overflow error and all that kind of stuff. But actually, the strawman argument is used then to say, right, well, we need strong typing, and therefore you fall into this aggregate typing. Let me just define what aggregate typing is for the audience, and it's a good kind of rich Hickeyism to use dictionary definitions, but the aggregate comes from the root of aggregate is gregare, which is to travel with, or if you think of a herd of animals traveling with. So you can have you can have values that travel together, like name and address and postcode can travel together for a particular business process, and then the name and the address and the postcode can decide to split up and rendezvous later on. And so it's the idea of an aggregate type is just defining that these things are just going to travel together. And I like that idea because they're not bound together. You're not tying the animals together. You're just saying, oh, I'm going to go for a walk. Let's all go for a walk together for this particular case. So I think the aggregate, the understanding that we must be very, very careful of binding values together to form clusters and compound types. This is the root of this rigidity in our systems. We should avoid that. I think, Joe, you did a great job of explaining why that is a straw man argument, and why let's try and think of. So I wanted to just move on then let's talk about aggregate types and better ways. I was going to introduce this kind of notion of defining, rather than defining a type, you just say, for the purposes of my business process, I would quite like, I'm going to be shipping a package to some customer, and I need to know their name and address and postcode, and that's it for my process. And so I would rather like to alert you if you don't receive this data structure, if it doesn't have postcode, I want to be able to fail. And that is like more of a linting thing. That's I like the idea that a linter is really just a set of constraints and checks and validation rules that you have at a particular time, that you allow a consumer to say, this is what I need. If you can't provide it, then there's an issue. This is something we need to raise.
And I suppose we also need to I guess we're in danger of some violent agreement, I guess. So so I'm interested in thinking, okay, if we try to be more flexible about these aggregates, what are some of the drawbacks or pitfalls of this approach that we tend to apply and find quite natural? One of them, I guess, is that you may find that at any given point in your system, you've actually lost track of what data is available at that point, because you've been so flexible with those aggregates that you really just don't know. And you need to think, oh, well, I need to start using a piece of data here. My system, this function was not using it up until now. I'm pretty sure it's in this map and I can use it, but I'm not certain. So that's a reality, right? That we also, is one of the consequences of being so flexible about those aggregates. I mean, I've got ideas about the strategies that we use. Now, you could say, yes, this is where, you need to think about what are some good boundaries along which to do some validation of what data you're working with. And you might restrict that, like I say, to only the parts that you're interested in. And you might say, well, definitely at the edges of my system, API sort of boundaries, I'll check it there. You might go a bit deeper and say, okay, I'll have a sort of modularized code base, and between these modules, I'll be a bit stricter about the structure of data that's being transferred across. Again, the nice way about this, nice sort of characteristic of gradual typing is that you do get to choose where you think is most appropriate for introducing, some sanity checks. But I'm interested in, people's experience of that problem, losing track of what data is where.
I've definitely got thoughts about this. So I've flip-flopped back and forth between type languages and dynamic languages. Often it'll be writing a lot of type stuff at work and then doing some sort of hobby project, and I'll choose a dynamic language to do it. And I get this initial sort of discomfort going back to the dynamic world, because I'm essentially trying to use typed approaches and techniques in dynamic code, and it doesn't work very well. And one of the biggest problems I have is keeping track of my usually function argument data types. What shape are they, especially if they're relatively complicated maps of vectors of maps or something like that. And you think, oh, as you know, as much as I purport to love dynamic types, I would love for the editor to just tell me exactly what I have here. And then a week or two goes by, and I forget all about that. And I think, as you said, we have perhaps a different way of approaching those problems. And so I don't think if you took someone who loves static typing and then said, hey, try dynamic typing, just do everything you do normally, but don't bother with the types, I don't think they would have a very good time. I don't think that would be the best way to introduce them to the ideas that we're talking about. But I think you've also hit on a really important point, which is dynamic and static is only one aspect of a much more complex intertwined system. And so, for example, if you have access to a REPL, you're in a very different space to if you can't inspect what you've got there and then. Because if I've got a REPL, I can just literally in line in the editor say, well, kind of print it to the screen for me. I can just look at it, and I'm not looking at some abstracted perfect version of it. I'm looking at the actual data that's come through, and that helps enormously. And then the other thing I think is that with typed systems, I think and one of the points I'd noted down is that it's so easy to make really deeply nested layered systems. So your sort of system, your wider business logic can go down through so many functions via so many classes. And if you try to do that in a dynamic language, it's going to hurt probably quite a lot because it is difficult to keep track of. You can't just keep hitting Control B on IntelliJ and going, tell me more. And so, and I think it's a good thing that dynamic languages give you the feedback to say, well, is that really necessary? Maybe you want to have two layers. You've got all of your sort of utilities, and then you compose them together into the answer in the other layer, which is sort of the business logic or whatever. And I love that feedback, because when I start losing track of my system, I go, oh, time to stop. I've made a mess here. And with a type language, you just keep going and on and on and on. Having said that, if I crack open an open source project, do I like it being in Java and being able to explore it with an editor? Yes, I do. That is an upside that is hard to argue against.
Yeah, it's like the tools to make large code bases easy to navigate. That you need to be careful with those tools, because they can actually make some very large and overcomplicated code bases easy to navigate. And I guess it potentially there you're not seeing some of the downside. I do agree that a lot of those systems, we sort of pick on Java because it's like but it's usually a frame of reference that I think a lot of people are familiar with. It's amazing how many Java systems do tend towards this endless series of layers. And that's a lot to do with the types, right? Because the types that you've used to represent an HTTP request need to be mapped into types that you have used to represent your own API, and then those types need to be mapped into something in the middle that has a different view on the data for your business logic or whatever, and then those types need to be mapped into something that you're using to persist. And if you're careful, sometimes you can collapse these, right? And you can say, we're going to have a type here, and we're going to try to annotate it in all the right ways, or do what's required to make this type relevant across all these layers. But really, you very soon hit the limitations of this. And so I think you do see the nature of a lot of Java systems is just mapping from one representation to another, endless layers that are only about mapping from one representation to another. And it's mostly down to the types. It's because the language is not really giving you the tools that you need to leave data in an essential form that all of these layers will find easy to work with.
Yeah, that's right. Every layer of abstraction needs its own type system. So you're sort of at the HTTP layer, you're quite happy with strings because they're request headers. But further down, you want dates and you go with other structures.
It's like where does the business logic live? It's normally some strategy pattern or visitor pattern. It's like where the heck is that? It can be really difficult to find. It's in the most obscure place half the time.
Yeah, and to sort of counter my own point before, I said I pop open an open source project and I like being able to navigate it. Typically, I then do struggle to understand what's going on.
You can navigate it, but
Yeah,
you don't understand where you are.
And then when you finally understand it, you think, oh my goodness, so they've literally just essentially called one function to transform a data from one shape to another. It could have been 5 lines or something. And all of that complexity collapses back down again. And it was all a waste of time to begin with.
I think one thing that's good about, maybe it's unfair to sort of constantly harp back to like Java examples, because it's almost like saying, well, the world of static typing, I'm going to use, an example from 15 years ago, a language, that hasn't really, well, some people might take issue with that, but you know what I mean? Like examples from, 10, 15 years ago, and that's going to be our straw man for static typing. So it is true, of course, that a lot of languages make defining the types that you're working with something that is much less of a chore than it would be in Java. They provide actually a good, really nice ways of easily and quickly describing data classes or record types, and actually without a lot of ceremony, you can define quickly, just describe some aggregates and just say, okay, with nowhere near the amount of ceremony that we might traditionally associate with kind of Java and OO as an approach. So that I think there's definitely, it's worth acknowledging, I guess, that there has been an evolution in how much ceremony is required even in statically typed languages. Now it doesn't sort of remediate all of the different some of the issues that we've resolved, but it has provided a quicker experience to just quickly defining the shape of your data and then working on that type. In languages like Scala and Haskell and Kotlin and things like that. In even Java now, there are better and better tools to do that with minimal ceremony. It has to be said.
I think on that one, I agree, and I don't think it's helpful to bash on Java in the abstract. We should probably talk about the actual sort of specific behavior that it has, like nominal typing, for example. And I think this is maybe a good time to get into the sort of, well, are we just moving data around, and are our types data? When I do TypeScript, I think pretty much always, all my types are data. They describe data. And what TypeScript relatively trivially allows you to do is define a subset of that data. And you can define it because it's structurally typed, not nominally typed. I don't know if it's worth getting into that a little bit for the audience. Otherwise, it's going to waste their time for the next 5 minutes. So nominally typed language says if you have a sort of type of package ID, you have to pass in some sort of boxed string, probably of package ID. You can't pass a string in. You can't pass something in that has exactly the same shape and the same underlying data type. And a structurally typed language will say, well, as long as the fields overlap, you're good to go. We won't stop you. And TypeScript is structurally typed. And so you can do things like say, well, I want to pick these 3 fields from this other type and make that all I need in this function. And then it will structurally match. And starting to flirt with schemas here a little bit, you can choose to say, by definition, let's say I've got my package type. I either want to pick fields from package. So if package changes, this thing changes. Or you can say, no, I need ID and name. And then if package changes, you get a compilation error. And that is hugely flexible as to whether you're saying, well, I definitionally want a subset of a schema, or I definitionally need these exact things. And I can layer it on as much as I want. And I think the reason we probably keep going back to Java is it's one of the examples where, as far as I'm aware, at least, there are no real mechanisms to do that sort of thing. You just can't do it unless maybe you have a 200 long list of interfaces that you're satisfying, perhaps.
And yeah, that's I think is a really good distinction between nominally typed and structurally typed. And as you were explaining structurally typed, I was thinking of other analogs in GraphQL has that feature, JSON schema has that structural feature, and I think perhaps we are ignoring some of the benefits of structural typing. That said, I was going to make a case that actually you use the word understanding your code base when you open up a new code base. It actually It is a lot of ceremony as an author of code to come up with names and good coherent names. But if you do so, you begin to create a language of the system, which is very useful for the reader understanding it. They can start understanding, looking at name, just in the same way we use names in language. We give names to things like biscuits and things. You can start using that and learning the language of the system, and that definitely aids understanding how code works to a point. I don't want to labor that, because sometimes you understand a process and you realize, oh, it's just added two numbers together. Ultimately, it's just got all the names get in the way. So there is some second order benefit to having names, and I don't want to deny that. And I think that's why it is a bit of pros and cons. Having no names at all in the system and no comments, and it's just data shapes moving around, it's become very, very difficult to understand what's going on.
I agree, and I think that cuts two ways. One, it can be fantastically helpful. You go, oh, look, someone's left me a trail of breadcrumbs, and I'm absorbing information a lot faster because of the types. And then other times you have to expend a lot of mental energy and then reduce the clarity in your code because you have to name this thing. It's an interface. I don't want to call it the sort of the real thing, but it's not. And and so we've at my work we've come up with this thing where we call the interface what it is. So a big query client, and then the instantiation is the network BigQuery client. It's a bit clumsy. They're all just BigQuery clients, and obviously we name the variable BigQuery client. So I think that you do get. Or the argument, I should be more specific with my terms, but I'm sure you know what I mean. I think you get a lot of mileage in naming your variable names, your value names, your arguments well, and not using. I think this is maybe where some of Clojure can go downhill a little bit. Is these really pithy names, and unless you're in the in group, and Scheme is frankly a bit like this as well, then you have no idea what's going on because you think there's an F here and a XY there, and it's very difficult. But if you just give things good full names, it's often enough, I think.
Yeah, so labeling is important, and often I think there is a case for saying X and Y when it's very local and very obvious what's going on, and but having good labels is useful for the reader. But let's finish up by touching on schemas, because as I understand it, if you're writing a function, you want that function to assert its inputs rather than just fail randomly or break. You sometimes want to say, oh, I need to have a date of birth. It needs to be not null, otherwise I'm just going to fail in an undefined way. So you use preconditions. You might do assertions. The problem with preconditions and assertions, of course, is that you can't really communicate what the requirement is to a caller. You can just say, well, I'm going to run these assertions. And that's the value of a type system, is that at least you can communicate to what's calling you. But it's not the type system isn't the only way of doing it. And one way of doing that is to have a sort of precondition language, which let's call it a schema, which I can say, let's just check the inputs. And if I can code that schema in something that can be represented in another language, I can communicate what my requirement is. It might not be the whole type. It might be I just need the name and the address. I don't need the postcode, but I can communicate to the outside world or to callers of my function what my requirements are. And I think that really is what people want. And what they do is use types. But what they really want is that little ability to represent a requirement in something they communicate to the outside world.
And to be fair to them, I would say that with the tools that we have available now, it's probably the best way to do it. I strongly feel that it's not the only way to do it, and I don't know if you use Emacs to do Clojure development, and Cider, but I think is it CLJ Condo that essentially the linting tool. I get squiggly red lines now when I pass a vector and it was expecting a dictionary or something. It says no, you probably don't mean that, and I think you can get a lot of that back if someone's willing, or some people are willing to put the investment into the tooling. So you could have a schema JSON schema, say, and you could use preconditions enclosure, say, and then your tooling, when you're calling that function, could give you that information. And then you're all the way back to almost as good as types. And then the conversation very strictly becomes, do you need a static pre-shipping thing to stop you from being able to make this into a binary? And it really sort of narrows that argument down to just that question.
So one thing we haven't covered yet is that we talked a lot about data and different aggregates of, aggregating data in different ways, using types to represent those aggregates. We haven't talked about typed effects. So I think, I guess the holy grail for the statically typed language is to be able to have a compiler that is telling you that you've wired up your function calls and the interactions with your data correctly. Once we talk about having an effect on the world and whether we've done those things in the correct order, often all bets are off at that point. Your compiler is not going to be telling you that you've done those things correctly. If we move into the world of typed effects, what it's effectively doing is bringing side effects or changes into this world of statically validatable and statically compilable correctness. So I wondered, Jake, if your interactions with TypeScript has this stuck to defining data structures, or have you started to move into the world of typed effects in your TypeScript as well?
So I don't know anything about typed effects at all. So that sounds like something very interesting for me to go and learn about. Can you give me a little bit more information about them and possibly?
So, I mean, like I say, you can think about this is, I don't claim to be an expert. I've done, some Scala development in my time. That's my exposure to typed effects. But if you think about a side effect in call in another language, right? Something that you would struggle with is whether you have pieced together those side effect in calls in the right order. As soon as you introduce kind of, a semicolon, which is I've done this thing, that's the end of that, and I'm going to do something else. You've basically introduced a problem. You can no longer say whether these things are done in a correct order. Effectively, the compiler is not going to help you. But what if we could encode those effects as types and then make assertions about valid ways in which those effects can be chained together? Then we could actually see all of the steps in our program as one compilable, validatable value effectively. So what the typed effect is there to take a side effect in call and represent this as a value, and then we can validate this value. We can have rules around how those values are checked and whether they are connected together in the right way. And it's bringing you to this holy grail of being able to truly validate everything about your program in terms of its correctness. So not just the interactions with data structures, but now every side effect that those are being done in the right order and one change to the next in the correct way. And so that's the value. But I think it also brings a lot of downsides. But it's interesting because I think often where we have languages, we have statically typed languages. I think there's a kind of path here where those that are interested in static languages and continuing to statically validate as much as possible, it does lead you down a path of the community moving ever closer to typing everything, including not all data, but effects as well. And this brings with it a lot of weight of theory and baggage then that has to be kind of learned to get anything done.
So I'm really glad you brought this up because I think it's fascinating. And one of my sort of interests on the side, if you like, in a very armchairy way, is more low-level embedded systems, things like self-driving cars and real-time operating systems, safety-critical systems, aeroplanes, that sort of thing. And then people's lives are on the line. The mistakes that you make cost dearly. And so it's from a system designer's point of view, absolutely fascinating and critical to think about whether you're getting whether the techniques that you have are powerful enough, and whether you might have more powerful techniques that you could use to make it much less likely you'll crash a car or poison someone with too much caffeine in a vending machine or something like that. I don't think that whether a thing is a string or an integer speaks very much to correctness. So I do think that if we're going to go down that road, you probably want something much closer to what you can do dynamically in a schema and say, well, this is a listy thing that has at least one object in it, and that object must have an ID. And that ID has to be a non-empty string. And then it might become useful again. But I don't... my understanding is that types came about because you needed to know how your data was laid out in memory. So you're going to start at some address, and then you're going to slurp up enough of it until you've got all of your objects, and then you can interpret that meaningfully. I don't think anyone started that game going, oh, I'll model a domain, I'll model banking with that. I don't think that's what it's for. I don't think it's very good at it. But I am interested. I'm not completely anti-static analysis, but I think it does need to get more powerful. And there are languages out there that have investigated this, aren't there? I can't remember their name, which kind of tells you everything I think about it. It's very it's a research concern, isn't it? It's not in industry yet, as I understand it.
Well, great. Well, before we answer what is a monad, I don't think we need to. I think we're coming to the end. I think thank you to our listeners. That's a very cathartic experience for us. So thanks for indulging us. Any final words before we conclude this satisfying discussion on types?
Well, I just one final word, like types and shapes and form and things that are important enough to take out of your code base and to express in a way that every language and everybody in the organization can kind of understand. And I don't think we need they're too important, these things. Type systems, I think, are not the way that we should encode business rules and processes and understanding, and we should, where there are definite better formats for those things. And I think types often get in the way of us then searching for those better, more business-friendly languages.
Yeah, and I couldn't agree more with Malcolm. And I think if you very quickly realize you do need schemas because you can't trust what comes over the wire, and then you find yourself auto-generating your code anyway. So you're not even using types in that way to begin to in the end. So yeah.
Very good. Well, thanks, John. Thanks, Joe. Thanks, Jake. And thanks, John.
Thank you very much. Thanks, everyone. Cheers. Bye-bye.
Thanks for having me.